Alright, hello, this is Blank L, and today we are going to be going through the O-Levels Cambridge Examinations Mathematics Syllabus D paper from October-November 2002. So this is a pretty old paper, so we don't really need to go through the instructions, but for the most part, the paper is a total of 80 points or 80 marks, and all the marks are designated on each question as we see over here. Also, all questions need to be answered in the provided section. So here, otherwise they do not actually check it. However, this is an older paper, so I'm not sure if this is still the way that Cambridge actually proceeds with their papers. This is obviously paper 1. I think this is the paper that does not have a calculator, but generally for my videos, I like to do these without calculators, and I would suggest that people also do most of these papers without calculators if you're not obviously doing timed practice. If you are doing timed practice and the paper requires a calculator, then you may use a calculator. But if you're just practicing to learn math concepts and doing older papers, I would suggest just try to do them without a calculator. And obviously, if you're having to divide and multiply decimal spaces to the 9th or 6th decimal place, then yeah, totally use your calculator. Anyways, let's get this started with question number 1. Question 1, the first question is express 17 over 40 as a percentage. So to get a percentage out of anything, what we simply do is multiply the fraction by 100. Get it in fraction form and multiply it by 100. So that would make this 1700 over 40, right? And now what we can do is cross out these zeros and then just divide 170 by 4. And I will do this via long division, which is 170 here and 4 here. 4 4s are 16. That leaves us with 1. We carry the 0. 4 2s are 8. That leaves us with 2, and then we can add a decimal point here and add a 0 here. We can add a million zeros here if we wanted after that decimal point. For the most part, 4 5s are 20, and so we have our answer 42.5%. All right, so far so good. Let me just make a little division. I used to do this when I took these papers as a kid as well. Just make a division there so that we can do our question number B, or our question part B. This is part A, this is part B. So part B is find the decimal number, which is exactly halfway between 4.7 and 5.0. So you want to find the number which is the midpoint of 4.7 and 5.0. Now we can write 4.7 as 47 over 10, and we can write 5.0 as 50 over 10, and so the midpoint would be some number m over 10. So simply we can just find the midpoint between 47 and 50, which would be the average between those numbers. So we add 47 to 50, 4 plus 5 is 90, and 7 plus 0 is 7, giving us 97, and now we can simply divide that by 2. So half of 7 is 3.5, half of 90 is 45. We can add these two together to get 48.5. However, that is not the answer, since our answer is actually 48.5 upon 10, which if we divide anything by 10, we just simply move this decimal over here, which would give our answer to be 4.85, and that is our answer for part B, 4.85. All right, we can now move on to question number 2. So question number 2, part A, is 7 1/4 minus 6 2/3. Now, what we can do here is, let's just imagine 7 circles. So 1, 2, 3, 4, 5, 6 and 7, and then 6 circles. 1, 2, 3, 4, 5, and 6. And then this last circle, we only have this part of this last circle. So actually, let me just make it so we only have a quarter of that last circle. And for this last circle, we'll split it into 3, and we only have 2 of those parts. So these whole circles, we can just cross out 6 of these. So what we really get left with now is 1, since there's one whole circle, and then 1/4, and minus 2/3, since we have 2 out of 3 of a whole circle and 1/4 of a whole circle. Now what we can do is we can convert this into a mixed fraction. So this becomes 1 becomes 4/4 plus 1/4 minus 2/3. And obviously 4/4 plus 1/4 would make it 5/4 minus 2/3. Now, some of these are things you guys can obviously do in your head, but I like to write them out so people can understand what the actual thought process of things is. So now what we can do is, since we don't have a similar base, we can't actually subtract these, right? So we have to make this base same. For that, we can simply identify the lowest common multiple of 3 and 4, which is 12. So to get to 12 from 4, what we can do is we can multiply both of these by 3. So 5 into 3 over 4 into 3, and then multiply that side by 4. So 2 into 4 over 3 into 4, and this would become 15/12 minus 8/12, right? And then 15 minus 8 is 7, so the correct answer would be 7/12. Now I know that's a very long way to do that, but just to sort of clear out the thought process, I wanted to list down the entire process. I don't really have space for the second question, but I'll try to make space over here. So let's just make this little boundary so we know we're not confusing any mathematics from the first part. The second part is simply 3 into square root of 2 multiplied by 5 into square root of 2. And another way we can write this is 3 multiplied by square root of 2 multiplied by 5 multiplied by square root of 2. So once we've written these out in this way, we can actually multiply the numbers that we know how to multiply pretty easily. So we multiply 3 by 5, which gives us 15. And we multiply the square root of 2 by the square root of 2, which gives us 2. And now we can simply get our answer, which is 15 multiplied by 2, which is 30. All right, let's move on to question number 3. So question number 3 is factorize this. So what I can see right away is that, well, that is a mistake on my part. Make sure when you copy the question, you copy it correctly, because that is a mistake I've done quite a few times as well. And it's a mistake that happens, but as long as we are aware of what we're doing, it shouldn't be that big of a deal. All right, so we basically want to break this middle term to make sure that the two numbers that we get can add together to make 5 and multiply together to make 6. And the two numbers that I can think of right away is -2 multiplied by -3, which makes +6. And also if we add these together, plus -3 equals -5. So what we can simply do is break that middle term and simply write -2x minus 3x, because basically if we were to simplify this, add these together, this would just make -5x again. But anyways, and then +6 at the end. Now we can break these terms further by taking, essentially what we can do is we can take these two and these two. I should have included that negative sign Reverse these two and just take out what we think is common, essentially, from both sides. So the first thing that I think is common is obviously x from here, so that remains. So that basically leaves us with x into x minus 2. And from this side, what is common, I think, is minus 3. And then look at what this leaves us with. This also leaves us with x minus 2, right? And so now we have our factorized form being x minus 3, which is what we took out, and what remains in the bracket, which is x minus 2, and that would be our answer for question number 1, x minus 3 and x minus 2. Lovely. And you can obviously multiply these with each other, and you should come back to what we had in the question. All right, again, I've left myself very little space for part B, but maybe we can suffice. We might need to make ourselves more space though. Given that x is equal to 4 is a solution of the equation of this, find the value of z. So simply, we know that x is equal to 4 is a solution of this, so we can simply put 4 in place of x. So this would be 4 squared plus 3 into 4 plus c equals 0. As a solution, if we put 4 here, the answer should be 0, since it's already told us that that is one of the solutions. So 4 squared is, I'll continue over here, 4 squared is 16 plus 12 plus c is equal to 0. 16 plus 12 is 28 plus c is equal to 0. Now I can subtract 28 from both sides, so this would be 28 minus 28 plus c equals 0 minus 28, right? And then since this is cancelled, what we are left with is c is equal to negative 28. So that should be our answer. C is equal to negative 28. So before we solve this fourth question, I actually want to give you guys a little bit of insight on formula. So one of the formulas that we need to use in this question is this formula, which is m minus 2 into 180, which basically gives us the sum of interior angles. Now, how this formula comes to be is something that I want to let you guys know. Obviously, if you don't want that, you can just skip this video to the part where we actually start solving it, and there should be a timestamp below for that as well. But so if you want to know why we use this formula and how we actually get this formula, essentially you have a triangle. So this is for regular polygons mainly, is where you would see us using this. So we have a triangle and we have 60, 60, 60, which is a regular triangle, right? And a triangle has three sides, and the sum of its interior angles is 180 degrees. Okay, so far so good. Now let's move on to a regular four-sided polygon, which is a square. Square has 90, all four sides, 90, 90, 90, okay? And it has four sides. Now we know that the sum of 4 into 90, it would be 360, but 360 is also 180 into 2, because this is 4 minus 2 into 180. And how we can figure this out is actually we can split this square into two triangles. So now we have two triangles whose both interior angles are equal to 180, and then when we do 180 into 2, we get 360. And this would work with other regular polygons as well. So let's make a, that is a very bad drawing. Let's make a 5-sided regular polygon. So here we have a 5-sided regular polygon. This is 5 sides. So And by the way, here n is the number of sides. I should have mentioned that earlier. N is the number of sides, so we already know based on our formula it would be 5 minus 2 into 180, which would be 3 into 180, which would be 360 into, let's add 180 there, so 460 plus 60 plus 80 would be 540. So that would be 540, right? We already know this would be the case, but how would this be the case? Well, let's just connect its edges. So let's connect that edge, and that is 3 triangles, which are 180. 3 times 180 is 540. And now to see if we could do this like in another way, because you might be thinking, okay, I'm just making triangles out of these edges, but you could connect any edges. So let's connect these two edges, and it's still okay. I didn't connect that edge correctly, but let's connect that edge correctly. So again, 3 triangles, 3 into 180, which is 540. So now we can actually go solve the question now that we know this formula for getting the sum of interior angles. All right. So coming back to this question, we see that each interior angle of a regular polygon is 150 degrees. Calculate the number of sides of the polygon. So what we want really is that n and n minus, in our formula, which is n minus 2 into 180. We don't have this n, but we do have what all interior angles is. So if it's the sum of interior angles, would it not just be the one interior angle multiplied by however many sides there are? So there are 60, for instance, in our triangle, each interior angle is 60, and then there are 3 sides. So 3 into 60 gives us this. There are 4 sides here, and 4 into 90, which is what they were before we split them into triangles. 4 into 90 gave us 360. So wouldn't it just be 150 into n, which would give us the actual answer? So now we can sort of take these out, multiply both of these. So this would be 180n minus 2 into 180, which is 360, is equal to 150n. And then we can simply subtract 150 from both sides. So let me get 180n minus 150n minus 360 is equal to 150 and minus 150, and I'm trying to keep the space of the answer. All right, so this would cross out from here. 180 minus 150 would leave us with 30 and minus 360. So now we can add 360 on both sides, which leaves us with 0 plus 360 here. Right, so these would cross out here. 30 n is equal to 360. So now n would just be 360 divided by 30, which is literally just 36 divided by 3. So 3 ones are 3, 3 twos are 6, and our answer is 12 sides. All right, let's move on to question number 5. So question number 5a says, evaluate 15.05 divided by 0.5. So one way we can write 0.5, or this whole equation, is really 15 divided by half, because 0.5, another way to say 0.5 is half. So now dividing. Now when you're dividing with a fraction, what you can do is actually flip that fraction and say you're multiplying with the flip of that fraction. So what this really becomes is 15.05 multiplied by 2, which we can just do that directly. 15 into 2 is 30, and 0.05 into 2 would be 0.1. So our answer, quick and easy, is just 30.1. The second question is that the rate of, so let me mark my A and then give myself some space for B. Okay, I don't like that I'm not consistent with my dots and brackets, but anyways, so the rate of exchange between Swiss francs and British pounds was 2.4 francs for each pound. So calculate the number of pounds received in exchange for 60 francs. So if 2.4 is equal to 1, what would 60 be equal to? Now we can cross multiply, but what we can simply do is see how many 2.4s are in 60. And to do that, we can simply divide 60 by 2.4. And another way we can write this is divide, again doing our fractions, divide this by this, which would then become multiplying 60 by 10 over 24. Right, so far so good. Now we can also write this simply as 60 over 24 into 10. So all I've done is taken this and put it under here. We can simplify this by 6, so 6 tens are 60 and 6 fours are 24. Now it's simply 10 into 10 divided by 4, which is actually 100 divided by 4, and that's a pretty easy solution. That equals 25. So we are going to get 25 pounds for our 60 francs. All right, let's do question number 6. So on a journey, a cyclist traveled 1 kilometer in X minutes. On a second journey, the cyclist traveled for Y hours. So there's a difference here. Hours at the same average speed as the first journey. Find an expression in terms of x and y for the number of kilometers that he traveled on the second journey. So the first thing that we need is actually the speed of the cyclist in the first journey, and that is the same speed that we would apply for the second journey. So speed has a simple formula, which is distance over time. Now, since one of them is in hours and one of them is in minutes, it's better to convert both into the same. So you can convert it into minutes, but the easier thing is to convert minutes into hours. So to convert, let's say if we have 120 minutes, if you wanted to write this in hours, we could simply divide this by 60, and this would give us 2 hours, right? So similarly, we can simply take our x and divide by 60, and now this is our time in hours. So what we have here is our distance, which is 1 kilometer, divided by x over 60, which gives us our speed as 60 over x, because it would be, we would just flip this and we would multiply it by 1, so it would be 60 over s. Now we have the speed. Now we want to know the number of kilometers they traveled in that second journey. So distance has a pretty easy formula as well. Distance is the speed and the time you traveled in that speed. So speed into time gives us linear distance. So we already have our speed, and now all we have to do is multiply it with the time, which is y hours. So this gives us a simple answer of 60y over x. All right, so far so good. All right, B, this is some indices. Let's see. So it is, we need to find the value of n, which is right here, so tiny. So first of all, I would like to write this in the form of converting all of these into indices. So far so good. The last thing we will do is into t. So if anything is in a decimal, we give it a negative power, and then the square root of something is actually it raised to the half power. So this is actually t to the power of 1 into t to the power of 3 into t to the power of half, which is equal to t to the power of n. Now the bases are same. There's a rule of indices where things are multiplied. You actually add the powers. So 1 plus 3 minus half is equal to n, where the bases are same. This is equal to this. All right, so 1 plus 3 is 4 minus half. That would be n. And now what we can do is we can write this as 4 over 1 minus 1 over 2, which can be then written as 8 over 2 minus 1 over 2, which gives us 7 over 2, which is 3.5. 0.5. What we could have also done is realize that half can be written as 0.5, so we could have done 4 minus 0.5, which would give us the same answer of 3.5 as the value of n. Alright, let's move on to question number 7. So expressed as a product of prime factors, now I love prime factor questions, is 198 in its prime factors and 90 in its prime factors. So use these results to find the smallest integer k such that 198k is a perfect square. So first I need to actually tell you what a perfect square is. A perfect square is basically a number which when you take the square root of it, you get an integer as an answer. So what that means is, let's say 16, when we take the square root of 16, we get 4. So 16 is a perfect square. If we had a square with sides 4 by 4, that would be a good square because that would give us the area 16. Whereas if we have a number like 2, it is not a perfect square because we don't get an integer as an answer. We get something like 1.4 something something something. I don't exactly remember what the square root of 2 is, and that's not something you should know either. But what we basically want is a number that gives us an integer when we get the square root of it. So let's use 16 to further figure out how this could be. So if we express 16 as its prime factors like they have done here, we can basically, let's do that here. So 16's prime factors are, first we have a 2, that makes 8, we have another 2, that makes a 4, then we have another 2, makes a 2, and then finally we have a 2, which then leaves 1. So 16 in its prime factors is just 2 to the power of 4, which we can also write as 2 to the power of 2 multiplied by 2 to the power of 2, which if we take the square root of this, so 2 to the power of 2 multiplied by 2 to the power of 2 square root, will just give us 2 multiplied by 2, which gives us 4, and that basically solidifies that this is a perfect square. It's a perfect square number. We could have also taken the square root of 2 to the power of 4, by the way, because if we write this in indices form, this would be 2 to the power of 4 over 2. Since we know from the previous question, we can write this as this. So anything that this power already contains would just be added here, and these two would essentially cancel out. So we could have simply done this, which would have given us, again, 2 squared, which is equal to 4, which is what the square root of 16 actually is. So knowing all of that, how do we make it so that these numbers, 2 into 3 squared into 11, I almost wrote 16 instead of 11, into 11, if we get the square root of this, we get an integer. Currently, we would get 3 into whatever this would be, 1.4, and whatever the square root of 11 would be, which would definitely not be an integer. So we need to multiply these by a number k, which would essentially make it so that our integer, so that our numbers basically become numbers that can easily be, that we can easily get the square root of, and we would simply just cancel these out, and that would give us the answer, right? So that's what we want to do in theory. How could we do that? Well, we could simply do 2 into 3 squared into 11, and we multiply it by a number that gives us both a 2 and an 11. So we multiply it by 2 into 11, 2 into 11, which gives us 2 squared times 3 squared times 11 squared. And this would then just give us 2 into 3 into 11 if we get the square root of this. And this number is, well, 2 into 11. That's just 22. So our answer would be 22 in its prime factors, that would simply make it so that our number very easily becomes a square, a perfect square number. Now, obviously, we could have done 2 squared and 11. No, we could not have done that because that would make this 3 and this 3, which would not give us a perfect square. For a perfect square, these need to be even, as we learned with 16. So, but we could have done this. We could have done this, right? We could have done, hold up, let's erase all of this and do this again to see if we could have done this. So we could have done 2 into 3 squared into 11 into 2 cubed times 11 cubed, which would probably be a huge number, right? And this would give us 2 to the power of 4, 3 to the power of 2, 11 to the power of 4, which if we got the square root of, this would also be a square, this would also be a perfect square because this would give us this number. However, what they wanted was the smallest integer k. So this is clearly not the smallest. What we really want is to minimize both of these values. And the smallest value these can take is simply 1 and 1, which is 2 into 11, which is 22. Now that was a lot of mathematics, but I hope you understood that, and let's move on to b. So the b is simply the highest common factor of 198 and 90. So first you need to know what factors are. So if I say, let's list all the factors of 20. So the factors of 20 are all the numbers that can be multiplied with each other to make 20. So for this we have 1 and 20, 2 and 10, we have 4 and 5, and do we have any more than that? I don't think we have any more than that, but let's just confirm. 5, and then nothing with 5, nothing with 6, and then we would just be repeating our list, right? So these are all the factors of 20. So if we, and then what we do here is we divide them into their prime factors. So the prime factors of 20 would be 2, and then another 2, which would make it 5, and then 5 and 1. So 20 in its prime factors would be 2 squared into 5, which essentially, if you multiply these, you can kind of get sort of all the factors of 20 in here. So 2 into 5 is 10, and then a 2 gets left over, which makes 20. That gives us a factor, of 20, as well as 4 into 5 is also 20. And if we make the whole thing 20 into 1 is also 20. So every number can be expressed as a multiplication of its prime factors and also just a multiplication of its factors. So what we want to find is we want to find the highest common factor, not necessarily the highest common prime factor, but the highest common factor. And we have both of these numbers expressed as a multiplication of their prime factors. So to get the highest common factor, we can just take what's common in both of these and simply multiply that. So we see that they both have a 2 in common, and they both have a 3 squared in common. And this is the highest number that they would have in common. And then this number would obviously be multiplied by 11 and be multiplied by 5 to give you these numbers. So the highest common factor that these guys would have would be 2 multiplied by 9, which would be 18. 18 is a number that they both share. For 198, 18 gets multiplied by 11, and for the other one, for 90, 18 gets multiplied by 5 to make 90 and 98. But 18 is a factor that they both have in common. Like for 20 and 10, 10 could be 1 multiplied by 10 or 2 multiplied by 5. 20 was 1 multiplied by 20 and 2 multiplied by 10. So 2 was a factor they both had in common, as well as obviously 1 was a factor, but 1 is a factor everyone has in common, so we don't really mentioned that, but 2 was a factor that they had in common. This is not their highest common factor, but these are both factors that they have in common. So there we go. We have our answers, 18 and 22. Oops. All right, let's move on to question number 8. So an article in a newspaper reported, let me just change back to red. An article in a newspaper reported that the number of crimes had been reduced by half from 1991 to 2001. The article contained the bar chart shown here, I'm assuming. Explain why this bar chart might be considered misleading. So it says it was reduced by half. So what we would be expecting was that this would be half of this one, but it's much lower than half. And that is because it seems to start at 400, whereas if it was started at 0, this would be half of that. So we can simply write the y-axis starts at 400, which makes the 2001 graph look smaller. Now obviously my answer doesn't fit, but what I assume they're looking for is this part, the y-axis and the 400 part. As long as I think you identified that, you should be okay. All right. As for part B, the histogram alongside shows the distribution of times taken by a group of students to travel to school. 11 students took at least 5, but less than 10. So this one is 11. This one is 11. 10, less than 10 minutes. Complete the table with these. So if this one is 11, and we have how many squares here? 1, 2, 3, 4, 5 and a half squares. So 5.5 squares equals 11, which I assume it's just 5.5 into 2, which is 11. So I'm assuming I can just multiply each one by 2. So 2 and a half, 2.5 into 2, which is 5. So this would be 5. And the number of squares in this segment is 1, 2, 3, 4. 4 into 2 is 8. So the number of students here would be 8. I think that's pretty quick and easy. All right, let's move on to question number 9. The temperature at 0900 is -4 degrees Celsius. The temperature at 1500 is 14 degrees Celsius. Find the difference between the two temperatures. So this is pretty simple. It's just 14 minus -4. And if we subtract a negative number, we basically add the numbers together. So that will be 18 degrees is the difference between the two temperatures. If you want to know why we do this, we can basically imagine a number line where this is 14, this is -4, and this is 0. And so we want to find the distance between here and here. When we want to find the difference, what's the difference, like how many steps you need to take to get from here to here. That is the difference between them. So we have 14 steps from 0 to 4, and then 4 steps from 0 to -4. So we can just add 4 steps here to get to 18, and it would be the same number of steps as getting from here to here. So we can just add 4 to 14 to get 18 degrees. The second part of this question is assuming that the temperature rises at a steady rate, find the temperature at 1300. So it basically means that every hour, so every plus 1 hour, the temperature will increase at a steady rate. We'll call it x. So plus x degrees every hour. So in 6 hours, oh, my answer was 14 by 18, by the way. I should have, good thing I noted that down. I wrote 14 there, but let me also switch back to my red. So this was 18, right? So in 6 hours, our temperature rose by 18. So that means in 1 hour, it would rise by 3. So at 10, my temperature would be -4 plus 3, which would be -1. At 11, my temperature would be -1 plus 3, which would be 2. At 12, my temperature would be 2 plus 3, which would be 5. And lastly, at 13, my temperature would be 5 plus 3, which would be 8. And then 14 and 15, we would get to where we just were. So for BI, the temperature at 1300 would be, it would be 8, right? And then now B part 2, the time when the temperature is 12.5 degrees. So every hour, the temperature rises by 3 degrees, right? That means every half hour, every 30 minutes, the temperature would rise by 1.5, right? So at 13, it would be this, which we just figured out. And at 14, it would be 14. Wait, no, at 15, it would be 14, right? Let's also figure out what it would be at 14. At 14, it would be 8 plus 3, which is 9, 10, 11. So at 14, it would be 11, which is not quite close to 12.5. So we can add another 30 minutes. So at 14:30, it would be 12.5. There we go, which is what we wanted. So our answer would be 14:30, because for every 30 minutes, we add 1.5. For every hour, we add 3 degrees. So simple addition and subtraction, nothing much required here. Some division required, but for the most part, it's just figuring out. And obviously, you didn't have to do all of these. You could have just seen how many hours were between these and then just multiplied 3 by, so 9, 10, 11. So 10, 11, 12, 13. So 4 hours, you could have just multiplied 3 by 4 and gotten the answer. And then same goes for the other question, which you could have just multiplied this, or you would have rather just divided 12.5 by that, and you would have gotten the answer as well. Okay, now we are on to question number 10. A sum of money is divided in the ratio 4 by 3. The larger part is $720. Find the smaller part. So before we even do this, let's just get a quick lesson on ratios. So let's say we have $100, right? And if it's 4 by 3, this is 4 plus 3. This is 7 total parts that we have. And obviously, they're split into 4 parts and 3 parts. So instead of 100, I'm actually going to take 70 because that's an easier number to divide. So if we divide these into 7 parts, we will get $10. So we have $70 and we'll get $10 in each part. So one part would be $10, right? One part would be $10. That means 4 parts would be $40 and 3 parts would be, well, $30, and that would make the total be $70, right? So similarly, now we know that in this equation, our 4 parts are actually $7.20 basically, right? So we need to get to 1 part and 3 parts, right? So similarly, when our 4 parts were $40, we could have just divided that by 4 to get our 1 part, which would have been $10. We can do the same with 720, or let's just convert it into cents. So 720 cents divided by 4 which would be 4 ones are 4, and then we carry the 332. 4 eighths are, I think, yeah, 4 eighths are 32, and this makes 180. So $1.80 is 1 part, right? And now what we can simply do is we can multiply this by 3 to get the smaller part, which is the 3 parts, to figure out the smaller part. So 180 into 2 is 360, and into 3 is 540. So $5.40 would be our 3 parts. Okay, let me make some space for my other question. I should really try to write straighter. I seem to get really slanted as I'm typing or as I'm writing, but I should try to write straighter. Express the ratio 700 grams to 1.75 kilograms in its lowest terms. Give your answer in the form m is to n, where m and n are integers. Okay, so we have 700, and we can convert the other one into grams as well, which would be 1,750 grams. So a quick way to do this would be to simply find the highest common factor of both of these. So 700, can divide that into 2, that makes 350. We can divide that into 2 again. 150 plus that makes 175. We can divide that by 5. So 5 3s are 15, and then 5 5s are 25. We can divide that by 5 again. That leaves us with 7, 7, and 1. So 700 can be written as 2 squared multiplied by 5 squared multiplied by 7 is 2, and then we can do the same with 1750. Now there's obviously a much faster way of doing this as well, but I want to do it with this method, and then we can also sort of do the trial and error method of we just take different numbers that we know that it can be divided by, and we divide both of them until we get to the lowest form. But this would give us a direct answer, so let's try to find the highest common factor that both of these numbers have. So this one can now also be, well, we can directly, can we do 2? Yeah, we can do 2, right? So 2 8s are 16, and then 2 7s are 14, and then 2 5s are 10, right? 2 8s are 16, 7s are 14, and then 2 5s are 10, correct? And then we can do 5. So 5 1s are 5, that carry 3, 37, 5 7s are 35, 2, and then 175, and then the rest is the same. So 5, 5, and 7. So this one is 2 into 5 cubed into 7. So to get the highest common factor, we can actually simply take whatever is common from these rather than whatever is the lowest from these, right? We just need whatever is common. So we do 2 into 25 into 7, right? Because this has a 2, this has a 2, this has 2 5s, this has 3 5s, that means it also has 2 5s, and this has a 7, and this has a 7. So we just take the 3 numbers that they have in common, which is 5 squared, 2, and 7. So 2 into 25 into 7, which is 50 into 7, which makes, well, similar number, 350. So we know that 352s are this. So the first number gives us 2. And we know that since we kind of did this here, right? This was 3, this was multiply. If we multiply this by 5, it would give us this. So if we multiply this by 5, it would give us this. So 355s are 1750. So we can simply write 2 by 5. And I don't think there would be anything else to do with that. Now, obviously, you could have also first divided both of these by 2, then another 2. or rather they wouldn't both divide by 2. You could have divided them first both by 2, so it would have given you 350 and 875. Then you would have divided them both by 5, and it would have given you something else, and you would have eventually gotten here as well. But a faster, or rather a more logical way to do this is to simply figure out their highest common factor, and then just see what you can multiply that to get these into their simplest form. So that is the answer. All right, let's move on to question number 11. So the first part of this question is the missing number in the sequence 1, 3, 6, blank, 15, 21, and 28. So there are ways to sort of figure out a formula for sequences, and I think this question is going to make us do that as well. But for now, I'm not going to really go into depth about sequences. I'll probably make another video about the different types of ways you can derive formulas for sequences and figure out what any term in a sequence is, whether it be one type of sequence or a different type of sequence. There are multiple types of sequences, as we're going to learn a little later. But the main thing you can do in a sequence is you can always figure out what the relationship is between two adjacent numbers in a sequence. What I mean by that is we can basically get the difference between all of these and figure out what basically makes it so that 1 becomes 3 and 3 becomes 6, and so on. So the difference between 1 and 3 is 3 minus 1 is 2, and then the difference between 6 and 3 is 3. We can't figure out the difference between these two, and we can't figure out the difference between these two, but the difference between these two is 6, and then the difference between these two is 7, and I'm just gonna make an assumption that the difference between these two is going to be 4, and the difference between these two is going to be 5. But even if like this doesn't tell us something, I'm just assuming this right now. But if this doesn't tell us something, what we can do is we can get a second difference. Now the second difference is going to tell us the relationship between these differences. So if we get the difference between these, the difference between these will be 1. These are my assumptions, so I'm not going to do it here. And the difference between these is also going to be 1. So I assume the difference between these is also going to be 1, and the difference between these is also going to be 1. Since I know that that remains constant from the numbers that they have given us, I can assume, I think my assumptions are pretty well formed, and I'm just going to think that the difference between these two is going to be 4. So 6 plus 4 is going to be 10, and I'm just going to put in our answer. Now there are formulaic ways to confirm that, but for the most part, to solve this question, I don't think we are going to actually need those formulas. Anyways, let's move on to B. The 7th term in a sequence whose nth term is 3n minus 1, we can simply replace n with 7 since n is any term, so nth term, so 7 is n in this regard. 3 into 7 minus 1, which is going to be 21. Oh, I need to be better at my writing. 21 minus 1, which is going to be 20, and that is going to be our answer, 20. Now this is actually a question that makes us make a formula. So an expression in terms of n for the n term in the sequence, so, and then that is the sequence. So what we can do again is we can figure out the relationship between these. So the sequence is 5, 9, 13, 17, and 21. Relationship between these two is 5 plus 4 is 9, 9 plus 5 is 13, right? Or actually no, 9 plus 4 is 13. 9 plus 4 is 13, 13 plus 4 is 17, and 17 plus 4 is 21. So when we have a difference like this, do you remember that the difference for these was actually changing, but the difference for these stays constant? This is called a common difference, and a common difference, I'm just going to type D here. So D is the common difference, okay? Common difference, which is in this particular term, it's 4. So when we have a common difference, this is usually the case with something called an arithmetic sequence or an arithmetic series. Why do we call these an arithmetic series? Because you can take one term, you can do some arithmetic to it, you can add 4 to it, or you can minus 4 from it to get the previous or the next term. So you can do some arithmetic to one term to get the next term. A generalized formula for arithmetic sequences is a plus n minus 1 d. So I'll explain what this is. A is the first term. So we can sometimes also write it as a0. A is the first term, which in our case is 5. N is the current term we're trying to figure out. So let's say we're trying to figure out the second term, which will be 9. So n would be in that regard 2, n minus 1, because we need to do something to the previous term to get this term, right? So that's why we do n minus 1. And then d is the common difference. So d is 4. So in this particular equation, our answer should be 9 because we're trying to figure out the second term. So 5 plus 2 minus 1 is 1. So 5 plus 1 into 4, right? And that gives us 9. And this, it would generally work for any sequence who has a common difference. This formula would work. So we can simply use this formula to now derive a generalized formula for our answer for the nth term. We need an expression, right? So we need an expression in terms of n. Now we can clearly simplify this. We have plus 4n minus 4, and then 5 minus 4 is 1. So we can simply get 4n plus 1 as our simplified expression in terms of n for any term in this sequence. And we can again test this out. If we add 3 here, like if we want to figure out the third term, we know that it should give us 13. So 3 into 4 is 12. 12 plus 1 is 13. All right, we are on to this latter half of questions with question number 12. So the population of Europe is 7.0 into 10 to the power of 8. And the population of Asia is 3.5 into 10 to the power of 9. The mean mass of the population of Europe, so mean means average, is approximately 62 kilograms. Giving your answers in standard form, so that would be so standard form is basically one main digit and then 2 significant characters. So this is usually what standard form refers to: 1 digit and 2 significant decimal places, usually, unless defined otherwise, but usually they would mention it if it was otherwise. Estimate the total mass of the population of Europe. So we have the total population and we have the average mass. So the total mass is obviously, so basically how we get 62 is 62 kilograms is actually the total mass, which is x divided by 7.0 into 10 to the power of 8. Now we can write this as well. We can also write 62 as 6.2 into 10 to the power of 1, right? So we can do 7 into 6.2 into 10 to the power of 8 into 10 to the power of 1, right? We could do that. What we can also probably do, which would probably be easier math, we could just make this 62 and forget about this and just forget about this, right? Because it would just be 62 into 10 to the power of 0, which anything to the power of 0 is just 1. So let's just do that. This is just 7 into 62, so 7 2s are 14, and 6 7s are actually 35, 42, 42, right? Yeah, 42, because 7 7s are 49. So 42, we add these together. 4 plus 2 is 6, and 1 plus 4 is 5. So 7 into 62 is, that's not right. Yes, that is not right, because we need to add a 0, and then because it's 7 into 60 and not 7 into 6. So this would be 42, and then this would be, whoops. this would be 4, 3, 4. So this would be 434 to the power of 8 into 10 to the power of 8, which in standard form, so the decimal is here. If we divide this by another 10, the decimal would be here, and then if we divide this by another 10, the decimal would be here. So we can write this as 4.34 into 10 to the power of 10, right? So okay, hold up. 4.34 into 10 to the power of 10. Okay, let's move on to the second half of the question. The second half of the question states, how many more people live in Asia than in Europe? So we just need to subtract this from this. So what we can do is we can do 30 or 3.5 into 10 to the power of 9 minus actually 0.7 into 10 to the power of 9. What I've simply done is I've moved the decimal over 1, which I increase, like I did here, I just increase the power of 10. So all we have to do is subtract 0.7 out of 3.5, which is also conveniently 4 into 7. And 4 into 7 is actually 28. 4 into 7 is actually 28, so we can just write 2.8 into 10 to the power of 9. That's how many more people are in Europe than in Asia. So 2.8 into 10 to the power of 9. And lastly, we have expressed the population of Europe as percentage of the population of Asia. So we've already expressed the population of Europe like this, so we can simply do 0.7 over 3.5, and I'm not going to write the 10 to the power of 9s because they would just cancel out, it's being divided, but we can just multiply this by 100, and we already know that this would be 1 over 5 into 100, which equals 20, so this is 20%. Moving on to question number 13, the region R is defined by 4 inequalities. 2 of these are x is less than or equal to 4, so this one right here, and x plus y is greater than or equal to 5, and I'm just gonna do that as 5 minus x. I'm just gonna write that like that, so that it's easier to understand, or rather like this, so that it's in the form that's easier to understand a line. So it's this line that's going negatively, right? Okay, write down the other 2 inequalities. So one of those inequalities is this, and the other one is this. So x is equal to 4 was this one, so this one, because it's a straight line and it's in y, this would simply be y is equal to 4, or rather, because we're defining R, it would be y is greater than equal to 2. Yeah, y would be greater than equal to 2 because it's above this line, and this one it's actually below this line, so it would be, well, we have R plus 1, and we have the gradient, which is simply the rise and the run, so we can do, let's actually figure out this gradient. So to get a gradient, what we do is we get 2 points, so let's get this point, which is 2 and 3, and this point, which is 1 and 2. And now what we do is we do y2 minus y1 over x2 minus x1, which would be y2 is this, so 3 minus 2 over 2 minus 1. 3 minus 2 is 1, and this is 1, so our gradient is 1. So we have our gradient, and if we just put it into the form of y is equal to mx plus c, which is where m is the gradient and c is the y-intercept, which is 1, we will simply get y is equal to x plus 1. However, because it's, it's lower than that, it should be y is less than or equal to x plus 1. And there we go. All right, time for question number 14. In the Venn diagram, in this answer space, shade the region A union B intersection with C. So what this question is really asking, and I'm gonna draw my own version of this Venn diagram. It's not gonna be great, but just to explain, what it's really asking is we have A union B, which is all of this, and we have that, and then it's asking what of that intersects with C. So what of all of this intersects with C? So what really of all of this, and I'm gonna get to use a separate color for this, what really of all of this intersects with C? And it's only this part that really intersects with C. So there's two ways to do this. I think Cambridge also in the past has said that like you can use two different colors to show, okay, what A union B and then intersection with C could be like. So you could do something like this to show that yes, this is the intersection with C and that is the correct color, and also perhaps provide a key, or you could simply just shade the region, which I'm going to try and shade within the lines, but you could simply just shade this region, which is the region of A union B that successfully intersects with C. So now let's try the second part of this. All 30 students in a class study at least one of the two subjects, history and geography. Twice as many study history as geography. 8 students study only geography, and by drawing a Venn diagram otherwise, find the number of students who study both. So we want to find the students who study both. We know that 8 study only geography. However, there are students who either only study history or study history and geography, and that's twice as many as people who either only study geography or study history and geography together. So in Venn diagram form, that would look something like this. This is geography and this is history. So in the middle are people who study both. These are only geography, which we know is 8, and these are only history, which we don't know right now. So I will call this X and I will call this middle one Y, just to give them values. So we know that X plus Y. So this bit, we know that this would basically be 830 minus 8, because just the people who that only study geography are out of this. So X plus Y, we know, would be 22 students. This would be this entire area, right? We also know that X plus Y, which is all the students who study history, right, is basically double all the students. So Y plus 8, so Y is both and then 8 is only. So we know that X plus Y, which is all the students who study history, is double as geography. So what we can simply do, and what we want to find out, is Y, which is all the students who study both. So what we can simply do is simplify this part, right? So 2Y plus 16, and we know that this part is equal to 22, so we can simply do this is equal to 22. Now we subtract 16 from both sides, so this would leave 2Y is equal to 6, which means Y is equal to 3. So there are 3 students who study both history and geography. Moving on to question number 15, the table shows the number of children living in the houses on a road. So we have 3 houses which have 0 children, we have 7 houses which has 1 child, we have 5 houses which have 2 children, we have 4 houses which have 3 children, and so on. So what is the modal number of children? So modal, or mode, which it says mode right here, so I should have just underlined this. Mode basically means the most occurring value. So out of this, we see that the most occurring value is actually 1 child, which 7 houses have 1 child. So the most occurring value is 1 child. Most houses only have 1 child on the street. All right, moving on to median. Median is basically the middle value. So there's 2 different types of medians. Let's say we have 5 values, right? we have 5 values. It's pretty easy to look at this and see that the median is basically the middle value, which is this value, which would be the third value for the median, right? And it's pretty easy to do with odd numbers, but what if we had 4 values? Now it's a little harder to do the median because there's no real middle, but these two are the middle. So to find the median of the fourth value, or rather to find the median of a list which has an even number of values, what you do is you basically get the average of these two values. So the median of this, which would actually be 1, but it would actually be 1 plus 1 over 2, which would eventually give us 1. So that's just something we need to know, because so in our range, how many total values do we have? We have 3 plus 7, which is 10. We have 5 plus 4, which is 9, plus 1, that's a 10. So we have 10 plus 10, we have 20 total values, which means the median of this will be the average of the 10th value and the 11th value. Now the 10th value is 1, since we have 3 values here, and then we have 7 values here, which gets us to 10, and that would be 1. But the 11th value would be the one right after that, which would be in this one, so that would be 2. And then we can simply do 1 plus 2 over 2, which is 1.5, and that is our median value. So the middle number of children on this street is apparently a child and a half. And lastly, the mean number of children. Now this is a straight up average, so we already know that there is a total number of 20 values, and now we need to actually see how many of those are. So 3 into 0, so there's 3 0, and we don't really need the 0, and then 7 into 1, so we have 7 children. We just need the total number of children over the total number of houses, essentially. So this is the total number of houses, and that way we'll have the average number of children in the houses. So total number of houses in 20, and now we're getting the total number of children. 5 into 2 is 10, so there's 10 children there. 4 into 3 is 12, so 12 children here. And lastly, 1 into 6 is 6, so this would be 17 plus 18 over 20, again, which is 35 over 20, and this would just be, well, 5 sevens are 35, and 5 fours are 20. And now we can do some long division to figure this out, because I'd rather give it as a decimal than a fraction. So 4 ones are 4, and we subtract that, so that's a 3.0. 4 sevens are 28, and that would be a 2, and then we add a 0 there, and that is a 5, and 4 fives are 20. I'm just going to erase that so that doesn't go leak into a different question, but our answer is 1.75. So the average number of children on the street is 1 child, and basically 3/4 of a child. Okay, so the next question is a matrices question. The first part is we have matrices A and matrices B, or matrix A and matrix B, and the first part is A minus 2B. So the first thing I'm going to do is, I'm just going to write them down: 5, 3, minus 2, and 0. And then here we have 2B. So when you multiply something by a matrix, you just multiply each value in the matrix. By that value. So by that, I'm just going to multiply 2 by each of these. So 2 into 1 is going to be 2, 2 into 3 is going to be 6, 2 into 2 is going to be 4, and 2 into minus 3 is going to be -6. So now when we're subtracting or when we're adding matrices, you just take whichever value is in whichever position, and you subtract that value or add that value to that position. So 5 minus 2, so we'll have a resulting matrix. 5 minus 2 is 3, 3 minus 6 is a -3, minus 2 minus 4 is actually going to be -6 as well, and 0 minus -6 is going to be 6. So we have 3 minus 3 -6 and 6. I will definitely have a video going into detail about matrices. I probably need to make multiple videos because there are multiple operations that happen with matrices. So moving on to part 2 of the question, we need to find A inverse. So one thing with matrices is when you multiply A by its inverse, you get an identity matrix, and an identity matrix is simply this matrix. It is 1 0 0 1. So it's first value 1 and then each other value 0 and second value 1, and if it needed to be longer we would just keep adding this in the diagonal of ones. So that is great, but there's a very long way to find it and then there's a short way. So there is a formula for this, and again I'll be making a video on matrices to go over all of these, both the formulaic and non-formulaic way to do these. But the formula is simply A inverse is actually equal to 1 over the determinant of A times the adjoint of A. Now, the determinant of A is simply found by multiplying these two and then subtracting whatever the multiplication of these two is from the multiplication of these two. So with that logic, 5 into 0, so what this would be 5 into 0, which is 0, minus -2 into 3, which is -6. So the determinant of A is going to be 6. So this is going to be 1 over 6 into the adjoint of A. Now another quick trick to figure out the adjoint of a 2 by 2 matrix is you flip these two values. So you flip 0 and 5, and then you flip the negative and positive values of these two. So you flip the sign of these two. So this becomes -3 and this becomes 2. So A inverse is simply going to be this, and now we could solve this out. We could multiply these, or we could leave these like this, and I think they've actually left us some space here to do this. So 2 and 5, right? So 0, -3, 2 and 5, and we can also check this by multiplying A by these, and that should give us this as the answer, and I'll leave that for you to do, but I can confirm that if you multiply A by this, you would get the identity matrix as an answer. And obviously, if you don't know how to multiply matrices, I will have a video on that. Now we are at question number 17, which says, given that a function f of x is equal to 3x plus 7, find first f of -2, which I guess I've already left the answer down there, but f of -2 would simply, we would just put -2 where x is there, so it would be 3 -2 or -2 plus 7, which 3 into -2 is -6, so -6 plus 7 would be 1. Yeah, -6 plus 7 would be 1. That's easy. Now we want to find the inverse of f. So the inverse of a function basically undoes what a function does. So if we gave this function -2, it gave us 1. If we gave its inverse 1, it should give us -2. Now I'm going to show you how to do this. So the first step is simply we replace f of x with y. So we do y is equal to 3x plus 7 just to make it easier for us. Now we actually want to swap x and y, so we want to do x is actually equal to 3y plus 7, and now we simply want to make y the subject again. So to make y the subject again, we're going to subtract 7 from both sides, so this is going to become x minus 7 is equal to 3y, and lastly we're going to have y is equal to 1 over 3 into x minus 7, and that should be the inverse of this function. To test it, we can put, so this is f inverse of x, which is this, and now we can add f inverse of 1 to test it, and the answer should be -2. So f inverse of 1 is going to be 1 over 3, 1 minus 7, which is -6, so it is going to be -6 over 3 which is going to give us -2, which correctly tells us that this function is actually the inverse of this function because it undoes to 1 what f did to -2. So our answer was 1/3 x minus 7, which was right here. All right, now we want to find a value of x for which f of x equals f inverse of x. So we can just make these equated to each other because we want a value of x to come out of this. So a value for x for which this is equal to x minus 7, oh, that's a plus, x minus 7/3. So I'm just going to multiply both sides by 3. So 3 3s are 9x and 3 7s are 21 is equal to x minus 7. And now I'll subtract an x from both sides. So this will become 8x plus 21 is equal to -7. I just subtracted x from both sides. And then lastly, we can just subtract 21 from both sides to get 8x is equal to -28. And this would make x equal to -28/8, which should be 14, no, which should be 14/4, and I don't think we can reduce that further. So -14/4, that does not look correct to me. Actually, we can reduce this further because this is going to then be -7/2, and I actually think that is correct. So -7/2, which we could have also written that as -3 wholes and then 1/2, but it doesn't really matter. So -7/2. All right, let's get on with question number 18. In the diagram, TB is a tangent to the circle center O. TO meets the circle at C and A. So TO meets the circle at C and A. D is another point on the circle, so this is just a random point on the circle. And BTC, so BTC is 22, which BTO would also be 22. Use the letters in the diagram to name 2 right angles. So we just need to name 2 right angles here. So T and B are a tangent to the circle on this line. So whenever there's a tangent to the circle, the radius to the tangent, the radius and the tangent will always form a right angle. So that is going to be a right angle, which means OBT or TBO is going to be a right angle. So I'm just going to write OB, and let's just let them know that that's where the right angle is. So OBT is going to be a right angle. Another property of a circle is that when a line passes through the center, or when a chord passes through the center, when that chord makes a triangle with any point on the circle, it is going to be a right angle. So these are just like circle properties. So this will also be a right angle. So A, B, C is also going to be a right angle. All right, now we need to find OAB. So we need to find this thing right here. So we know this is 22, and we know that this is 90. So we can find this simply by adding 90 and 22, which gives us 1, 1, 2. Correct? Yeah, 9 plus 2 is 11, and 0 plus 2 is 2, which gives us 1, 1, 2, and then this entire line would be, sorry, wait, we know that this is 22 and this is 90, right? So add these two, these are 1, 1, 2, and then a triangle has 180 total internal angles, so we just subtract 1, 1, 2 from that. That would leave us with, so this would be a 0, and then 80 minus 12 is 68, right? 68. So this little bit would be 68, which means this whole thing, because it's a line, the sum of these two should be 180. A straight line is at an angle of 180. So basically, you subtract 180 from, you subtract 68 from 180 and you go back to 112. So this side is 112. And now we also know that these two are the radii of the circle. So this basically forms an isosceles triangle where these two are equal, and we don't really know what this is. But for an isosceles triangle, these two angles, so this angle could be something else. In our case, it's 112, but these angles would be the same. And we know that it would like and we know that all the internal angles of a triangle make 180, so we just subtract 112 from 180 again, we get 68, and then we just divide 68 by 2. We just divide 68 by 2 to get 34, and that is our answer, 34. All right. The next thing they want us to find is ABT. So we know that this is 34 and we know that that is 90. So this is pretty simple. It's just 90 plus 34, which is 12 and then 4. So that is simple. That is just 124 right there. And lastly, we need to find BDC. So anytime you have a chord like this, anytime you have a chord that makes an angle or a triangle with a point on the circle, basically, right? So these are two. This is a chord. B and C is a chord that makes an angle that makes two triangles with a point on the circle. So one of those is A, and one of those is D. Basically, both of these angles are the same. So we already found A in part 1, so this will just be the same as A. This is going to be 34 as well. All right, let's move on to the next question. The force of attraction between two magnets is F newtons. The force is inversely proportional to the square of the distance D between the magnets. So F is inversely proportional, means there's a constant K that represents their relationship to the square of D, right? When the magnets are a certain distance apart, the force is 10 newtons. What is the force when the distance is doubled? So we know that the force is 10 newtons when D has some value and when the relationship constant, which I'm defining as K, has some value. So honestly, we can give D any value. I'm just going to give D the value of 2. So this is going to be, D squared is going to be 4, which means K would be 40. And this is just to generate, because we know the relationship constant. This is a constant, meaning any number that we provide for D, it will have a constant relationship, a constant inverse relationship with the 10 newtons. So we can choose 2, and I'll try choosing other numbers to show you that this would work no matter what. So what is the force when this is doubled? So K is equal to 40. So if I double this, D is going to be equal to 4, which means D squared is going to be equal to 16. And now all we need to do is divide 40 by 16. Divide 40 by 16, which becomes 10 over 4, which becomes 5 over 2. 5 over 2, and that is also like 2.5. So let me just write that as 2.5, and I'm just gonna show you guys how this would work if we take in a different value of D as well. So let's just get rid of all of this, right? Let's just get rid of all of this. We just only have our relationship. Now let's say we take in a value of D is equal to 1. So in this case, 1 squared is 1. So K would have just equaled 10, because it would just be, 1 squared would be 1, and then we'll multiply both sides by 1. That would make the 1 here disappear, and K would just be 10. And then if we double this, which means D would become 2, right? And then 2 squared d squared would have been 4, and all we would get is 10 over 4, which is again equal to 2.5, which we just did. So the relationship, because it's an inverse relationship and we have defined a relationship constant, that constant basically remains constant and keeps the relationship intact. And I think I've already done this question in my calculations, but write down a formula connecting f, d, and a constant k. So that's just usually how I do relationship questions. So we already have this. We already have this sort of definition that we created. And it's really nice to sort of come up with a functioning formula when you're doing questions like these that require you to deal with multiple variables or a variable and a constant. And so I'd already defined it, and we can just simply write it there. When the magnets are 3 centimeters apart, the force is 2 newtons. Find the force when they are 5 centimeters apart. So when distance is 3, the square of the distance would be 9, and this is equal to 2, right? And then we need to get a value of k, which in this regard would be 18. Find the force when they are 5 centimeters apart. So 5, we'd simply divide 18 by 5 squared, which is 25. And this would essentially be the answer. And I think what we can do is we can just divide 180 by 25 and then just divide that by 10 again. So 180 by 25, 25 4s are 100, 25 2s are 50, so 25 12 would be 150, and then 25 into 13 would be 175, and then it would just leave a 5. So 25 into 13 would be, hold up, let me do this with long division so that it's easier to see, right? So 25 and 180, right? So 25 into, 25 into 13 is 1, wait, I am making some mistakes. 25 into 4 is 100. 25 into 6 is 150. 25 into 7 is 175. So 25 into 7 is 175. That leaves a 5 here, and then 0.0 there, and then 25 into 2 is 50. So our answer would be 7.2. However, we need to divide this by 10 because we multiplied it by 10 to make our math easier here. So we'll just divide 7.2 by 10, and that gives us 0.72. There was probably a faster way to do this if I just simplified these, but I just wanted to do some long division. Okay, we are now at question number 20. The diagram is the speed time graph of a car's journey. Find the speed when t is equal to 6. So I'm assuming this is 5, which means each of these would be, so that would be a 1, that would be a 2, that would be a 3, that would be a 4, and that would be a 5, which means this would be 6. And if we just draw a straight line from here, it meets it there, and this again, I think it's right in the middle of 10 and 20, which leads me to believe it's 15. Which leads me, these are 10 and they represent 10, so right in the middle would be 15. I'm just going to write 15 meters per second. The acceleration when t is equal to 6. So the acceleration is the rate of change of the speed. So it's basically how we define the rate of change in a graph is we simply, or like how the graph is changing over a value. So when we have like y and x, how we define the way y and x are changing is that we use the slope, because the slope tells us the rise over the run, which means how much the value of y increases when the value of x increases. if we take that similar ideology and we apply it to here, we can see we can basically use the slope to determine how much the speed increases as the time increases. So we can use the slope to figure out the acceleration, which is basically the rate of change of the speed as time increases, or how much the speed increases as time increases. What I'm basically saying is we need to find the slope at this point, and since this is a straight line, the slope would remain constant. So we already know this point, right? We know that x is equal to 6 here and y is equal to 15 here. And to find the slope, we need 2 points. So I'm just going to take this point because it's a pretty easy point to figure out that x is equal to 10 here and y is equal to 25 here. And now how we find the slope of a straight line is we do y2 minus y1 over x2 minus x1. And what these are is this is y2 and this is x1 and y1, and this is x2 and y2. So y2 is 25 minus 15, and x2 is 10 minus 6. So 25 minus 15 is 10, and 10 minus 6 is 4, and this is 5 over 2, so this is 2.5. 2.5 meters per second square is the acceleration when t is equal to 6. The distance traveled in the first 20 seconds. So this is the first 20 seconds. If I can draw a very straight line, that would be the first 20 seconds. So this straight line here, I'm trying my best, and this straight line here. Well, not this straight line, but I just drew that line to kind of separate between 10, 20, and so on, right? So this part, essentially, this entire part is the first 20 seconds. All right, I should probably Control-Z that. How do we figure out the distance? So the distance is basically speed into time, right? And if we see this as a square, speed into time would simply be the area of this square that we have. And then also over here, speed into time would simply be the area of this little triangle that we have. So basically, in a graph like this, how you figure out distance is you figure out the area underneath the graph. So the area here, so the area of a triangle is, for the first 10 seconds, the area of a triangle is half into base into height. That's just how you get the area of a triangle. And I can also explain why you do this as well, because a triangle is just a square split in half. So the square's area would be base into height, and then when we split it into half, we just get half that area to get the triangle's area. So the base of the triangle is 10, and the height of the triangle is 25, and then we also have a half here. Also have a half here, so half of 25 is 12.5, and then if we multiply that by 10, so 12.5 is half of 25, and then if we multiply that by 10, we just move the decimal over 1, and we get 125. So that part is 125, and then this part, so this is again 10 seconds here, and then it just remains constant. So 10 into 25 is another 250. Once we add 25 into 50, we get 375, and that is the distance that is traveled in the first 20 seconds. All right, what is this final part? The value of t when the retardation is greatest. So that has to do with knowing how the slope of curves works. So the slopes of curves usually have a turning point, either when there is the greatest and the least amount of basically the slope. Yeah. So when you have, let's say, a curve like this or a curve like this, here the turning point becomes basically, or the slope at the turning point basically becomes nothing, because at that point it's kind of turning. So when a car, let's say a car turns on a circle, right? A car turns on a circular road. The car has to basically get its velocity down to 0 to make this turn. So there would be a point in this turn where a car's velocity is completely 0, and that is usually the turning point. And a similar logic applies to a curve, where the turning point, the slope, gets its least value or goes to a 0 value. So we can figure that out as, so when this is a curve, and this is a curve, right? This would be, so this would be the turning point downwards, and this would be the turning points upwards, right? So in this regard, we have this point, which is the turning point downwards, which is when it starts decelerating, and then it starts decelerating, and this is when that deceleration hits a peak, and then the deceleration starts decreasing, and then it hits a peak again, and then it hits a low again, and it starts decreasing. So this point is going to be the point where the deceleration is the greatest, because after that point, the deceleration starts decreasing again, the slope starts decreasing again. So the slope increases, hits a maximum, the slope decreases, hits a minimum, and then the slope starts increasing again, right? A good way to remember this. This makes a sad face, this makes a happy face. A happy face has an increasing, so a happy face like that has an increasing slope. A sad face like that has a decreasing slope. Instead of an arrow, let's make 2. So this is a sad face, this is a happy face. He's happy because his slope is increasing, he's sad because his slope has started to decrease. So it is roughly this point, and I'm just going to use my ruler to see where that point might really be. So if I just turn this, kind of just place this here, right? I think the actual turn is like around here. So we can just see this little thing. Oh, it's trying to use the ruler as a guiding line. But we can see it'd be like in the middle of these two. It'd be like right here would be where the turning point is. So in the middle here would be between 25 and 25.5 or 26. So I'm just gonna do 25.5. All right, moving on to question number 21. Simplify 2e plus 3f minus 2e plus f. So that should be a pretty easy simplification. 2e plus 3f minus 2e plus f. So first of all, I'm just gonna multiply both of these by -2 to remove the bracket. So that would be 2e plus 3f minus 2e and then minus 2f. All right, these two cancel each other out, and then 3 minus 2f is simply just f. So that is the simplification. It is simply just f. Now solve the inequality a minus 2 is less than 4 into 5 minus a. So again, this is just algebraic simplification. A minus 2, and I can just multiply these by each of the values inside the bracket. So 4 into 5 is 20, and 4 into negative a is minus 4a. All right, now what I can do is I can subtract a from both sides. So -2 is less than 20 minus 5a, right? And then I can subtract 20 from both sides. So -22 is less than -5a. So if negative 22 is less than negative 5a, in the positive spectrum, 5a would actually be less than 22, because in the negative numbers, the more negative the numbers get, the greater they are. But on the positive side of things, the more bigger the numbers get, the greater they are. So 5a is less than 22, which means a is less than 22 over 5. And I don't think that can be simplified any further. Okay, lastly we have solve the simultaneous equations. So we have these two simultaneous equations. Let's just write them here. X is equal to 2y plus 11. And then I'm just gonna subtract 3y from both sides to basically make x the subject of this one. So we can just write 4x is equal to negative 3y plus basically 0. Right. What we can do now, we already have a value for x, or rather a substitution value for x. So we can just simply substitute that over here. 2y plus 11 is what x is equal to, and that's equal to negative 3y. All right, let's simplify this out, which would be 8y plus 44. 44 is equal to negative 3y, and now let's add y on both sides. So 8 plus 3 is 11, y plus 44, and this would be equal to 0. And lastly, we can get 11y minus 44 on both sides, so we get negative 44 over here, which means y would be equal to negative 4. And now we can simply take this negative 4 and plug it into our other equation. So we have 2 into negative 4 is equal, plus 11 is equal to x. So this is simply 11 minus 8, which is equal to 3. So x is equal to 3 and x is equal to 3 and y is equal to negative 4. There we have it. Okay, so for this final set of questions, I decided to switch the software because these questions require us to measure some things, and a Windows Microsoft whiteboard doesn't really have the capabilities to pull out a protractor, or it has a ruler, but it doesn't have like a compass and a protractor. And you guys will see real soon that we're going to need these things for these questions. So anyways, let's move to question number 22. 3 shops, A, B, and C, which are shown to us down here, are such that B is 800 meters due south of A, and such that C is 1600 meters from B on a bearing of 120 degrees. The positions of A, B, and C are shown below. Another shop, D, is 1200 meters from C on a bearing of 057 degrees. So complete the map to show the position of D. So first we just need to calculate, basically, or rather measure what that 057 would be. So we put this at C, let's put this at C, and then move down because I don't see this right now. And so start from 0. So I'm looking at this one because that one starts from the opposite end. So I just want to get to 57, which is roughly there. 57, which is roughly there, and I'm just going to make that mark. And what else do we have? Right, the map is drawn to a scale of 1 centimeter to 200 centimeters. So 1 centimeter is equal to 200, and it is supposed to be, or 200 meters. So 1200 meters is just 200 into 6 gives us 1200 meters. So 1 into 6 would be 6 centimeters. So we just need to find the point. We just need to draw a line basically 6 centimeters away from C, that is in this angle. So let's get our ruler out, and let's see, start from C, and 6 centimeters along this line would be, if we just do this. That is roughly 6 centimeters along this line, and now I can get rid of this bit so that doesn't confuse anyone who's looking at this. All right, so that is where D would be. And let me just make this a little tinier. So this is D. Okay, that's the first part done. So second part is a new shop is to be built, and it needs to follow these 3 conditions. So the first condition is equidistant from B and C. So the second condition is nearer to BC than BA, and the third condition is at least 1200 meters. So at least again 6 centimeters away from C. So the easiest thing to figure out would be what is 1200 meters from C. So for that we need a compass, and we're going to place the compass at C, and then we're going to just measure 6 centimeters because that is 1200, and right, this was 6 centimeters, right? So 6 centimeters, and we just draw a line. You can see that our D is a little bit more than 6, but that's okay. It is roughly 6, right? So this is 6 centimeters away from C. Oh, wait, did I draw a line at 5.6 instead of 6? So let's just make sure that this was 6 again. It is a bit confusing, but it's okay. So yes, so anything within this circle would be below 6 centimeters or 1200. Anything beyond this circle would be at least 1200 meters away from C. All right, the next thing we need to do is equidistant from B and C. So to get the region that is equidistant from B and C, we just need to find the perpendicular bisector of B and C. And to find the perpendicular bisector, first we'll need a compass. We need to extend it at least like a little bit more than half, and then we'll draw this. We'll draw this indicator. Oh wait, we will draw this indicator and do the same thing. Actually, let's do this with a different color. Let's do this with red. So we'll draw this indicator here, and then we'll draw the same indicator down here. And then we can do the same for B. We'll just put this at B, and we're going to draw this indicator, and we are going to draw this indicator, and that is going to allow us to find the perpendicular bisector of, actually I have a line tool, so let me just use the line tool. I'll use my black color again. So use the line tool, and this is going to be, so anything on this line will be equidistant from B and C. And lastly, we need to be nearer to BC than BA. So for that, we need to basically figure out the bisector of this angle, because this angle is what is separating this BC and BA. So the bisector of this angle, anything below that would be nearer to BC, anything above that would be nearer to BA. So again, first we're gonna start from B, and we are going to basically split this line. Going to split this line, and then we're gonna come down here, and we're going to split this line, and then we'll come to this line, maybe extend it just a little bit so that our indicators actually meet. So let's mark an indicator over here. Maybe make this a little bigger, mark an indicator over here, and do the same on this side by marking an indicator over here, and then we'll do the same from this and mark an indicator over there. That's quite a huge indicator, but that's okay. And mark another indicator over here, and now again I can use my line tool to draw a line from these indicators, and that basically bisects our angle B. So anything below, and I think I'm probably gonna have to extend this line, right? So let's extend this line as well, just so both the lines meet. So anything, according to our question, at least nearer to BC than BA. So anything below this line is going to be nearer to BC than BA. Equidistant, so anything on this line is going to be equidistant from B and A, and anything beyond this circle is going to be more than 6 centimeters away from C. By constructing 3 loci, which we've just done, corresponding to 1, 2, and 3, find where the shop could be built and label the extreme points S and P. So S, and let's use the color red for this again. So this point, this is the extreme point, one extreme point, and then basically like on this line would be the next extreme point. I'm guessing because I've zoomed in, the circle doesn't actually collide with the lines, but I'm assuming on an actual paper where it's not zoomed in, the circle would have collided with these lines and we would have gotten a point. But right here, somewhere on the circle would basically be a P, which is the minimum point, and this would be S, which is the maximum point that is equidistant from C, really far away, or at least 1200 meters away from C, and also nearer to BC than BA. So that is our question. So I made a bit of a mistake on this question, and I just need to point it out. So our point P won't actually be here because our point P actually needs to be equidistant from B and C. And so any place where P can be, it has to be on this line. So it would be really somewhere on this line here that is the closest to this. I think, again, the zooming in is what's kind of made this bad for me, but I think if this was like to scale, like if my zooming hadn't like screwed it up, I think the circle would have collided with this line somewhere, and that is the place where point P would have been. So point P would have been the closest, essentially, the closest to this, but also still being on this line, still being on this line right here, and still being under this line is where point P would have been. So anywhere on this line that is closest to the circle or right on top of the circle, and I do think it's closest right here, so that's where I'm going to be putting my point P. So that's just a tiny little mistake that I made, and I did need to clarify it. So let's look at question number 23. So describe fully the single transformation which maps, the diagram below shows 3 triangles A, B, and C. So we have 3 triangles A, B, and C. Describe fully the single transformation which maps triangle A onto triangle B and onto triangle C. So for B, it's pretty simple that this is just like a reflection, and we can actually see that it's this line that is directly reflecting it. This is kind of just a visual observation. So we can simply write that this is a reflection in y is equal to 4, which is this line, right? The second one is a little more complex. It looks like, well, it's not being enlarged, and it's definitely not being reflected because clearly it's like, you know, in a different direction. So perhaps it's being rotated, but how is it being rotated? So I can see that when I connect, let's say, these points, right? When I connect these points and then do the same from like there, if I was looking at like a center one, it's clearly that there's some sort of rotation happening there, where it goes from like this to like that. But what exactly is the rotation? So let's connect the points and find perhaps our center of rotation first to even see if this is a rotation. So I'm going to pull out a compass again, and we are going to bisect these lines. So let's first bisect this line, and I'll use my mouse again. So, oops. So maybe I should zoom in for this a little bit. It would be easier to see these. All right. So to bisect these lines, first let's make it a little bit more than half. Let's use red again, right? A little bit more than half. And make an indicator over here, and then go over there and make an indicator over there. And then we move you up to A, And we'll do the same thing. We will make an indicator over here and make an indicator over here, and we can take our black line and connect these two. That perhaps, I think I've moved the background a little bit. I assume it would have been a straight line if we hadn't connected. So this basically is the perpendicular bisector of this line that's this long. And now let's figure out the perpendicular bisector of the other one. So again, a little bit more than half, which that is a little bit more than half. Let's go back to red for this, or maybe let's try blue for this one. Let's go to blue for this one, make an indicator here, and then also let's make an indicator here. I want to extend it a bit just so they meet, and then do the same by coming to C and make an indicator here and make an indicator right here. And let's connect both of those with a black line as well. And when we see both these perpendicular bisectors, we see that these perpendicular bisectors meet at this point. And if this is a rotation, this would be the point of rotation where the two perpendicular bisectors meet. And let's see if we can actually figure out if this is a rotation using this point. So just visually, this point and then this point right here and this point right here, clearly there is a rotation, and it even appears to be a 90-degree rotation. We could also, we could also use a protractor to do this, just to be like 100% sure. We could 100% use a protractor by putting that protractor right there. Let's put this protractor like right on this line, and you can see that like the 90 degrees. So that point becomes that point through this center of rotation with a 90-degree rotation. All right, so we can just go back up and let them know right here that it is a rotation. Let me go back to my block. It is a rotation with center, what was the center? With center 1 and -1. And also, I guess this is because this is a British exam, let's use the British spelling of center, with center 1 and -1, about 90 degrees. Or you could also write it is a 90-degree rotation about the center 1 - 1. I've just written it in a weird way, but it covers all three things that we need, which we identified that's a rotation, we identified that the center, and we identified how many degrees it's being rotated by doing all of this. So let's look at the final part. Triangle A is mapped onto triangle D by the transformation represented by the matrix, this matrix. And then we just need to draw and label D. So how do we do a transformation through a matrix? Well, we simply do the matrix multiplied by the original, and that gives us the image. So our matrix is -2, 0, 0, -2, and this is also an enlargement because it's just an identity matrix, but it's multiplied by 2, multiplied by -2. So it'll just, it'll do some stuff, and we'll see. We don't really need to know that for now. And then our A is, let's see what the points of A are. So this is, I should probably zoom out again. Yeah. So this is 2 and 1. So we have 2 and 1, and then we have 2 and 3. And we have 2 and 3, and lastly we have 3 and 1. 3 and 1. And this, I think I talked about matrix multiplication in a previous question, but obviously I'll create a video about matrices, and it would be up there if it has already been released. But anyways, let's just quickly do this. So the first part would be a -2. This would become also -2. This would become -6. And then the bottom part would become -1, -6, and wait, not -1, -2, -6, and -2, right? And I think I screwed up the top part as well because I was thinking it was -1 instead of, so -2 into 2 is -4, -2 into 2 again is -4. So -4, -4, -6, and -2, -6, -2. All right, and let me just confirm I got these correctly. So 2 and 1, 2 and 3, and 3 and 1. Yeah, so I do have them correct, and we can simply do this. We can do -4, -2, that's one spot, -4, -6, which is down here, and a -6, -2, -6, -2, and we can connect these dots together as good as possible, as good as we can, and we have our D. All right, let's come to this final question. So a rectangular piece of card measures 20 centimeters by 14 centimeters. Squares of side X, which we don't know what X is, are cut from the four corners, and the card is folded to make an open box. All right, so it's folded to make an open box. I show that the volume V centimeter square is equal to this. So V is equal to the length times the width times the height. Now we know that the height is X as it's shown right here. The length, which I'm going to take as this bit, is actually 14 minus 2x on both sides. And then the width is the same, it's 20 minus 2x on both sides. So if we do that, we have x multiplied by 14 minus 2x multiplied by 20 minus 2x, right? And so what we can do is we can take 2 common out of here, so we would do x into 2 into 7 minus x, and also 2 into 10 minus x, right? And then we can just multiply whatever's outside, so x into 2 would become 4x, and this would be 7 minus x, and 10 minus x, which is exactly what's up there, except I flipped the 7 and the 10, but it doesn't matter. And so we can say shown. All right, the second part, you are asked, not sure how that got there. You are asked to find the value of x, which will produce the greatest volume of the box. You should use the table and the grid to help you in your investigation. So we need to find the greatest volume. All right, so we know that x, and we're trying to find the relationship between x and v, which is 4x, 7 minus x, and 10 minus x, right? 10 minus x. So at 0, it just gets multiplied by 0, so this becomes 0. At 1, this is 4 into 7 minus 1 is 6, and 10 minus 1 is 9, so 4 6 are 24. 24 into 9s, 4 9s are 36, 9 2s are 18, 19, 20, 21. So this would be 216. So 216 on 1, and then 2, so this would be 8. 7 minus 2 is 5, right? 8, 5, and 10 minus 2 is 8. So 8 squared is 64. and that multiplied by 5 is 320, because half of 64 is 32, and then multiplied by 10 is 320. That gives us a 320. Let's do 3 and 4 and 5, and I think that should give us a good amount of values to compare. So 3, so 4 3s are 12, 7 minus 3 is 4, and 10 minus 3 is 7. Right. So 4 7s are 28, and then 28 into 12. Right, so there's probably a faster way to do this. So 4 12s are, let's just do 4 12s are first. 4 2s are 8, right, and 4 1s are 4. So 4 12s are 48, which is pretty simple, and then we can just do 48 into 7. So 7 8s are 56, and 7 4s are 28, plus 5, so 29, 30, 31, 32, 33. So we have a 336. Right here, 336. Okay, 4 4s are 16, 7 minus 4 is 3, and 10 minus 4 is 6. So 3 6 are 18. Actually, again, faster way to do this would probably be this one. So 18 plus 30 is actually 48. So 3 16s are 48, and let me just confirm that. 3 18, 3 1s are 3, yeah, 48. And now all we need to do is 48 times 6, which is 6. So 8 6 are also 48. And then 4 6 are 24 plus 4, so that would be 288. 288. So already we've seen a shift. So we've seen a rise, and then we've seen a fall. So it would be somewhere in between here is going to be the maximum value. But let's just do another. So 20, and then 7 minus 5 is 2, and this is 5. Right, so 20 into 2 is 40, 40 into 5 is 200. 40 into 5 is 200. So let's use our little thing here. So we have 0. Let's make this, let me make this a bit bigger. So let's make this 100, 200, 300, and 400, even though I don't think we're going to be using the 400. So at 0, it is 0. It should be here. At 1, we have 216. So have 2, 10, and then it would be like somewhere here. At 2, we have 320, so we have right here 320. At 3, we have 336, so that would be like somewhere here. Then at 4, we have 288, which is about here somewhere. And lastly, at 5, we have 200, which is right here. So I'm going to try to be as smooth as I can with this curve, but it's definitely tough to draw a smooth curve, especially with a drawing pad. So it would be like this, right? It would be like this, and then let me try to connect these dots actually. So it would be something like this, not the smoothest curve, but it's going to help us out. And then what we need to know is, we need to know the greatest volume. The greatest volume would be here, basically. It would be this one, and let's just draw a straight line to see where that reaches, and that is, it's roughly 2.6, but it's between 2.2, 2.4, so it's between 2.5 and 2.6. So I am just gonna say 2.55 perhaps, or 2.58. Right? We can just do 2.6. I think that should be okay as well. I think what they're probably looking for is that it's below 3 and above, like probably above like a 2.2 or a 2.4. Probably this is the region that it would always come up in. All right, and I think that was the entire O-level paper. So obviously hit the subscribe button for more past paper solutions, for more explanations, for all of these things. Obviously I will also have like playlists about subjects. I'll have playlists about topics. I'll have playlists about multiple things, and I'll also have playlists with all the past papers as I get through them. So this is just a beginning, but subscribe for more mathematics. I want to cover O-level, I want to cover A-level, I want to cover SAT, and then potentially I want to cover some advanced calculus as well. So thank you for watching, and I will see you later. Bye.